Okay, good evening, students. Welcome for another important, very important topic which we have before you, the D and F block elements. This is also a very important topic and there will be large questions from this topic, students, D and F block elements. You are already familiar when I discussed the periodic table students, when we discussed the periodic table student, the periodic table was divided in how many blocks? Tell me. Periodic table.
Four blocks.
We are saying the periodic table is divided in four blocks: S block,
P block,
P block,
D block,
D block,
and F block.
and F block. We are familiar with that, student. What is the basis of formation of these blocks? On what basis you are saying this is S block, this is P block, this is D, this is F block?
Sir, on the basis of where the last electron goes, in which orbital. If it goes in
Okay,
S block, then it is an S block element. That way.
okay. Therefore, that is a correct answer. You are saying when we are filling the electrons, when we write their electronic configuration, the last electron enters into S. We call it S block. The last electron is entering into the P. We say it is a P block element. And then the last electron will enter into the D. Then you will say it is a D block element. And if the last electron enters into F, you will say F block elements. That is the
Yes,
basis
sir.
of the four classification, student. Based on the there are s subshells or s orbitals, p orbitals. That's what you are saying.
Yes, sir.
D and F, four.
F orbital.
So it will depend the last electron is going in which orbital, in which subshell the electron is entering in the last electron. Therefore, students, we have a picture of the periodic table which we are familiar with. IUPAC periodic table of the elements is on the screen. As you can see that you have these are our S block elements, these are our P block elements, and this is our D block elements which we have shown.
Okay.
And here you have your F block elements, the one which we have shown. So you
Yeah.
have four blocks:
Okay.
S, P, D, and F. That is clear that the electrons must be going into D subshell here. In the last electron must be going in the D subshell. That is why you are calling them as transition elements. So therefore, we are saying from group number 3 to 12, group number 3 to 12 students, you are going to be your transition elements. ठीक है? Are
Okay,
going
sir.
to be your D block elements. First of all, I am saying D block elements. I will explain what is the difference between transition and D block elements.
Okay, sir.
This is our D block elements. Therefore, you are saying the D block contains elements from group 3 to 12.
12.
First point. The D block elements will be from group 3, 4, 5, 6, 7, 8, 9. So you are saying that the total of how many electrons can be accommodated in D, students? You begin with the 3D, or I am saying ND. In ND, you are going from 1 to 10
10.
electrons. So 1 to 10 electrons. So how many will be this from 3 to 12? How many will be these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by this end of here, from 3rd to 12th group student, we have D block elements. So the
Okay.
electrons are being progressively filled in the D subshell, in the D orbital. And as you see that here, once I come to, this is starting from which period, student? Which period is this? The
This is
our fourth period,
fourth period.
fifth period,
Sixth and
sixth
seventh.
period, seventh period, student. And in the fourth period, you are starting from scandium and you are going up to zinc for the D
Zinc.
block elements. Fifth period, this is our fifth period student. You are starting from yttrium and going up to cadmium student. But here something is happening. Here something is happening in the sixth period. Sixth period. When I say come to the sixth period student, sixth period, what is happening in the sixth period after barium? Barium is 56. As you can see, barium atomic number 56 student. Before that, which is the inert gas, you are coming from xenon. Xenon, what is the atomic number of xenon? 54.
54.
Xenon, you are saying is 54 students. And you are saying what will be the barium then, which is group is a barium student. Sixth period. So what will be the last subshell? 6s,
6. 6s.
6s2. So if you have 6s2 student, 6s2, then what is the story here? The next, if you have 6s2, after this, what will happen? What will happen? So this is 54 and 256. So this is 56. ठीक है 56.
Yes, sir.
And then which will orbital will be there students? You will have 54 xenon, and if you have 6s2 you will have 5d. So 5d, if I put 1, if I put 5d1, ठीक है,
Okay.
here what is, how many are there now? 54, 52, 56 and 57, atomic number 57.
57.
But as soon as I say 57, after that I am writing 57 to 71 are missing from here, are missing from here. See that 57 to 71, they are not here. That means
Yes, sir.
student, the 4f orbital is there, and this filling of 4f orbital starts. How many it can take?
Okay.
4f1 to
14.
4.
1 to 14.
So you are start getting a F block elements, F block elements here
Okay.
from the sixth period, from the sixth period, and they will continue up to, you start how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, actually it starts from cerium. Basically, the first will be, because this I've shown 5d1, 5d1, which is my lanthanum. After that, what will happen from cerium? What will happen from cerium? The first electron after this is entering into here. So you will have 14 elements, 14 elements, which in which the electrons are entering into the F subshell F orbital. So from here,
Okay.
when we after the 4f is completely filled, student, 4f is completely filled, then what happens? Then the filling of 5d starts, and this is our 3d, 4d, 5d series.
Okay.
So then again you get these 5d series, 5d element, 3d, 4d, 5d, first transition series, second transition, third transition series, and it will end up to atomic number 80, mercury students, mercury students. So
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, and this was the lanthanum. Uh, but lanthanum has not been kept here. It has been kept in F block for reasons we will tell you. The properties resemble more with this. It is not actually a lanthanide, but the properties of lanthanum resembles with lanthanides. Therefore, it is called. It has been kept in this group. Again, when I come to the seventh period, interesting thing is happening, students. Seventh period. Again, in the seventh period, student, 56. If I add 32, you are getting radium. If 57, I add 32, what you will get? 89. 89.
89.
So the last is 7s2. 7s2 here. Then what happens in this case, student? The one of the electron is entering into 6d1. After that, 5f will start, and you will have 5f1
Okay.
to 5f14. So again, this we have not written these here because the electrons have started filling the F subshell, F orbital. If I will write here, then it will become a very long periodic table. Therefore, we have taken them. This all belong to group 3. Both these belong to which group, student? Group 3. These are called
Group
lanthanides,
3.
and these are called actinides. 89, it's 89, 89. So from 89 onwards, actually the first element in which F electron is there in the F is thorium, thorium, thorium. You are aware of thorium is very important element. Thorium. These are mostly here are radioactive elements. So they will be difficult for us to do the study of them. Nuclear reactions will be taking place and they will be very dangerous to work with. And they need special nuclear, I mean, nuclear reactions need special things to be worked out that you are aware of. So you are aware of uranium 92 to 38. So these, you see that americium and all these elements, plutonium, you know they are radioactive elements. Radioactive elements, students. And more
Okay.
important thing, after uranium, what you find, student, this is a seventh period. This is our seventh period, student. Uh, after the seventh, after in the seventh period, this is our uranium. Uranium. After the uranium, these elements are man-made. They are made in the nuclear reactors. These are all made by the man. They don't exist. So they are called trans-uranium elements. This question,
Okay.
all the words I'm using are questions to be asked in the paper. Make it sure that you will
Okay.
record everything. They have asked what are trans-uranium elements, student. Trans-uranium elements. Which are the transuranium elements? Elements after uranium. Why they are called transuranium, student? They are not existing. They are made, man-made, synthetic
Okay.
in the nuclear reactions. So these are the transuranium elements, students. So we have started understanding the four blocks. S block, you are saying, okay, electrons are entering into filled in S orbital. P block electrons, the last electrons are filled in the P subshell. D, last electrons are filled in the D. And F, the last electrons are being filled in the F subshell or F orbital. That is clear to us, students.
Yes, sir.
Okay, this was the first part of it. Why did we take the periodic table? Because just to see that what type of elements are there, how many blocks are there. I have not defined the transition elements yet, student. Let me tell you. I have only talked the four blocks.
Okay.
Four blocks. So now questions, they say that question, all the transition, all the D block elements are transition elements. The answer is yes or no. I mean, see the story, how the questions are given. They give something. Now let us see. This up to now, I have defined the four blocks of the periodic and how you are getting lanthanides and actinides, the F block elements. They belong to which group? This question was there. F lanthanide and actinide belong to which group? They are elements of
Lanthanoids F block.
which group they are?
Uh, Lanthanoids are group 6 and actinoids are group 7.
Who said group 6 and
Sorry,
7?
period.
I'm not asked period.
Period
I'm saying
6
group.
and
See, this question has been asked. What is a
third
group?
group.
Third
Third
group.
group.
Lanthanides, third group. Okay, students. Lanthanides, third group. Period.
Lanthanoids are in period 6 and actinoids are in period 7.
And actinides again. Actinides, student. Which group? Three.
Group 3,
And period?
7.
Seven. These questions have been asked, student. See, don't think that a question, any question is there. Unless I understand, I don't know what I'm writing in the paper. All the students have done this mistake. They never wrote group 3. They are not aware of it. Now, once I am giving more attention, it is clear that such question will be good for us if it is asked in the paper. Because which simple question. Don't think they are asking difficult question. But a thorough study is required. Thorough study is required. I hope you understand the way I teach. Yes or
Yes,
no?
sir. Yes, sir.
Okay. So I have to work hard for you because I try to see the previous question papers of other exams and see how we can put questions to you. Every table is an information for us. And so we have to see, we have to get used to these elements which are present where this, all this we will see. So you have been told about four blocks: lanthanides, actinide, transition elements, transuranium elements. Transuranium, you are aware of them. They will come where? In which period? In which period there will be transuranium element? Which period is uranium, students?
Uranium is in actinoids. It is period 7.
Seventh period. And why they are called transuranium? They are made
Because
by,
they occur after uranium and do not occur naturally in nature, but are
and
prepared
we have made
synthetically.
them. So now the question starts. Students, you will ask me, sir, D, F, okay, what are transition elements? What are transition? What questions have been asked in transition elements? Before I start that, I have started. What is a transition element in chemistry, student? Hey, this question has been asked. This question has been asked in the paper. What is a transition element? So what is your answer, student? What you are saying? What are transition elements? What are transition elements?
So transition elements are those elements in which the last electron goes in the d and f orbitals, and they occur from group 3 to 12.
Now I'm not saying D and F because that will be transition, and F block elements. I have not said what they are called. They are called inner transition elements. First of all, let us be careful. What is a transition element in chemistry, students? Transition element. It is clear that electrons are entering into the D subshell. Electrons are entering into the D subshell, but which D subshell they are entering, student? You see that what was happening here. Yeah, there is a N NS NS orbital 2, and then there is a N minus 1 D orbital, student. N minus 1 D orbital. Now I have written something like this. How many electrons can be there in D? 1 to
To 10.
10. 1 to 10. What I am writing, student, I will explain to you why did I write that. The ns ns2, 1 or 2, okay, 1 to 2 supposing I say, and you have n minus 1 d, 1 to 10. This is a inner d orbital. This is inner d. It is not outer d orbital.
Okay.
Why it is n minus 1? Inner d orbital. This is called penultimate. It belongs to penultimate shell, student. I'm writing everything. This is n and this is n minus 1. The electron is going to go into n minus 1 d orbital, student. So in the transition elements, in the transition, I have not defined yet. I am only telling you. I am trying to explain to you what is happening. That when we will start filling the electron, students, you see that before that which group is coming? Group 1 and group 2, they have ns2.
2.
After
Yes,
that,
sir.
in the third period, what is happening? Fourth period, not third, fourth period. In the fourth period, if the period is fourth, then what is it? 4s2,
Yes,
4s2
sir.
outermost. And what is this then? 3d, 3d. So I say 1 to 2, okay, because some will happen. Then 1 to 10. This will be the first transition series. First transition series will be which one? Where which is the first transition series will, which d orbital will be the first one? 3d, 2d doesn't exist.
3D.
3d means and outside it will be which s orbital? 4s.
4s.
So and it is not a outer orbital, it is an inner orbital. This is called
Okay.
penultimate shell, or it belongs to penultimate shell. Next to this, before it comes before 4s. 4s is the outer, and this is penultimate shell. Outer shell, penultimate shell.
Penultimate shell.
Outer And this is our penultimate. I'm saying penultimate is a technical language, student, we are using. Therefore, now we will try to form the definition of the transition elements. Uh, the transition elements are those elements, students, which have what they said according to IUPAC. According to IUPAC, what they are saying, transition elements are those which have partially filled d orbitals, huh, in which that have partially filled d orbitals having a d subshell that is partially filled with electrons, or an element that has ability to form stable cations with incompletely filled d orbitals. This definition is given by the IUPAC for the
Okay.
transition elements. What it means? What it means? I'm saying transition elements are those elements in which which have in which have at least one unpaired electron one unpaired electron one unpaired electron in n minus 1 d orbital in in ground or common or stable oxidation state. Now the meaning is clear, student.
Yes, sir.
That means if the d orbital is completely filled, if d orbital is completely filled, student, there is no unpaired electron in the
Yes, sir.
ground state. Or,
Yes, sir.
or in other words, if in the stable oxidation state also, as I said, form cations. Cation means they lose electrons. Metals, they are metals. So metals do what? They lose electrons. You are saying transition metals. You are saying transition metals. They are metallic in nature. You are saying that.
Yes,
So
sir.
that means in certain common oxidation state or stable oxidation state, they can have one or more unpaired electrons. One or more unpaired electrons means the d orbital is not completely filled, students.
Okay.
If d orbital is completely filled, then dd transition is not possible. Another way of saying that. And therefore they are not transition elements, they are d block elements,
Okay.
because the last electron is entering into d,
To D.
but they are not
Okay.
transition elements. They are not transition elements. For example, when I will write the electronic configuration, student, what we are saying, for example, if I take student the fourth period, let me take the fourth period. ठीक है students?
Yes, sir.
Fourth period. I have just shown you. This is my fourth period, student. ठीक है? This is your
Yes, sir.
S block elements, which is that? First potassium and calcium. ठीक है? Okay.
Yes, sir.
If I do a mistake, you will tell me. Stay alert with me.
Yes, sir.
Keep the energy okay. I have a ginger tea which I keep, hot ginger tea, because you know that corona cases are rising in Delhi. I have
Yes,
to
sir.
be stable, and I am not going out. I am drinking hot tea, hot water, salt water. I gargle and put a lot of ginger before I make the tea. I am giving you the formula so that we can survive. The pollution level is high, and as the news says, there will be more cases.
Yes, sir.
Instructions have come from medical and government of India, so we have to follow this. And you are with me as a family member. All my students are my family, so I always give my best to the family members and tell you the right information and try to do a lot of research with you people.
Yes, sir.
Okay, potassium, and you are saying calcium.
Calcium.
What is the atomic number of calcium? Tell me, what is the atomic number of calcium?
Atomic number of calcium is 20.
20. What is the Atomic number of potassium
19.
19, 19, 20. And if you write the electronic configuration, this is fourth period, the helium neon, which argon 18,
Helium neon argon, yes sir.
and what is the next one? 4s2,
4s2.
4s2, 18 plus 2, 20.
20.
Okay,
Yes sir.
now I am coming to the 3D series. 3D series, which I am calling is the first transition series, student. Now I am saying transition series. ठीक है?
Yes sir.
Okay, I am writing students. Here I am writing. Supposing 3D, 3D student. Scandium, atomic number 21. Titanium, vanadium,
Mm,
chromium,
chromium.
manganese, iron, cobalt, nickel, copper, zinc. At least first series should be remembered by the students.
Okay.
If you can't remember all, but first, because most of in our course 3D will be the main thing. In coordination compounds also we will be using that. So when it starts from
Okay sir.
21 student, you are saying it is 22, 23, 24, 25 atomic number, 26, 27, 28, 29 and 30. ठीक है?
Yes sir.
Okay. If I see you are saying what you had, argon is how much? 18. Argon is 18 student.
18.
Then
Yes sir.
you are saying 4s2, and then you are saying 3d1. ठीक
1.
है?
Yes sir.
4s2 3d1. 4s2 3d2.
3d2.
4s2
3d3.
3d3. 4s2, if I write 3d4, actually this doesn't, that it changes into 4s1 3d5.
3d5.
Oh, in the reason also why it happened. I put a star here. Okay, all right. Sometimes they may ask you the electronic configuration, which we will discuss. What will be this manganese?
It will be 4s2
4s2
3d5.
3d5. What is happening here? 4s2
4s2
3d,
3d6.
4s2,
4s2 3d7. 4s2
4s2
3d8.
3d8, 4s2
4s2
3d9. This doesn't
3d9.
happen. It
This
changes.
also changes. 4s1 3d10.
Okay. ठीक है? Sometimes these
Yes sir.
configurations have been asked. I marked it with a red pen. I hope we know what we are doing. We know what we are doing. Be with me. Be with me. If I do a mistake, you will tell me.
Okay sir.
What is this story? 4s2
2
3.
3d10.
Okay. All right.
Yes sir.
They have asked in the exam, write the electronic configuration of copper. ठीक है?
Okay.
Let us see what this is actually. Which what is the group number? What is the group number? What is the group number? Okay. Group number. This was which group number? 3, 4,
3, 4, 5,
5, 6, 7, 8, 9, 10, 11, 12.
12.
Group number. Group number. One more thing is interesting here. Group number is 3. How many electrons are there? 2 plus 1. The 2 plus 1 is what?
3,
3.
3.
Group number is 4. 2 plus 2.
2 plus 2, 4.
4. 2 plus 3, 5.
5.
So this is also another interesting thing. And atomic number is 21. 21. 21 mean in
Yes, sir.
S2 and D1.
1.
22 S2 D2.
To 2 T2.
Eh, 23.
S2D3.
Here exception, so we are aware of that.
Yes, sir.
First I write S2 D4, then I write S1 D5. This is all, you see that how we learn the things, because they will be used. They won't give us they may give us only atomic number, then we have to write electronic configuration, everything. Now we see what is the connection, how do we understand them, so that our job becomes easier, easier, easier. It's all learning. We more we learn, more we learn. Now I said, okay, according to our definition of transition element, elements which have at least one unpaired electron in n minus d orbital. N minus 1 d orbital is known as penultimate shell,
Penultimate shell.
because you have seen this is a 4s, this is a inner one, inner shell. This inner 4s was filled first, then it is filled d, 3d. First 4s is filled, then d. See, what is n plus l of 4s? What is the value of n? 4, l is 0.
Every 0.
What is the n plus l of this 3d? 3, what is
N
d?
is 4.
pd.
3 plus 1.
5. Right or wrong?
Okay.
Right or wrong?
Yes, sir.
So then
Yes, sir.
when we filled the electrons, which rules we have used? Of Bohr principle.
Of Bohr principle and
What is the n plus l rule? The lower the n plus l, then that should be filled first. What we used when
uh,
we write the electronic configuration in 11th class, students,
of
Hund's rule of maximum multiplicity,
Hunt's rule and
Pauli
Pauli's exclusion principle.
principle. So n plus n rule here works out. This just to tell you how we are doing our work. We are not blindly putting anything. Okay. Now
Yes, sir.
tell me, according to our definition, is there any element here which is not a, which is a D block element but not a transition element? I'm saying
Sir, zinc.
name 3D element. Question now. Question. Name 3D element which is not a transition element.
Zinc.
You know Zn has 3D10.
3D10. Yes, sir. It does not
Is
have
the,
an unpaired electron and fully filled stable
if you
electronic
have formed
configuration.
zinc 2 plus, you know ZnSO4. If you form Zn2 plus, then what will happen? Electrons will go
Electrons will go.
from when the electrons go, they go from s first to the s first. Because n value, this is the outermost shell, this is the penultimate shell. Again and again I'm using that word. So Zn2 plus will be 3d10, 4s0. Got it?
Yes, sir.
So again there is no unpaired electrons. Therefore you can say that zinc is not a transition element. Zinc is not a transition element. This question has been asked in the paper, students. Zinc is not a transition element, but
It is a D block element.
it is a D block element. It has properties which are quite similar to these. Therefore, it is also kept in the transition metal series. It is also kept in 3D transition series.
Okay.
3D transition metal series because the properties resemble. When similarities are there in their properties, we have put it here. So we are aware of what the transition elements are, what are the characteristics of the transition atom. What are the characteristics of the transition elements? We will be studying their properties, but in general, they are good metals. You know, they are metallic in nature. You are saying S block are also very good metals. Did you not say that?
Yes,
That
sir.
means they are metals also. They are metal, but what is the difference? We will see that what differences will come in them, and they are metallic by all means. So they have metallic bonding. They have metallic bonding. If they are metal, they will be malleable. They will be ductile. They will be good conductors of heat. They will be good conductors of electricity. All those properties are going to be their students, shining, but they are much harder and denser than your S block elements. Yeah, you will see that. What is the
Okay.
reason for that? They are metallic in otherwise. That's what we are talking. Why are group 3, ठीक है? Why are group 3 to 12 called transition elements? Why are they called transition element group 3 to 12? What is saying that group 3 to 12? You have group 1,
Yes, sir.
2, and after that 13 to 18. These are the groups.
18.
These are
Yes, sir.
S, these are P. These
P.
are called transition. Why are they called transition elements? Student, transition means what? What is the meaning of transition, students?
Going from one to another. मतलब S में जो होते हैं elements, these are metals, and P block usually have metalloids and non-metals. So metals से non-metals के जाने के जो बीच में elements होते हैं transition.
Actually, transition, the meaning of transition is transition. There is a transition of properties as you go from S to the P.
P. Yes,
They
sir.
are lying in between strong
S and
metals.
P.
S are all metals, and when you come to P block, you have metals, you have non-metals, metals, non-metals, metalloids, and metals also at the lower type. So their properties of S and P are different. Now there is a transition of properties as you go from S to P. So that these elements have been sandwiched between S and P. Therefore, we call them as transition metal. Student, we call them as transition. ठीक है? Question
Okay.
answered.
Yes, sir.
I am talking of questions here, which questions are straight away in the paper, so we have to answer them. They have been asked. What are transition element example you are already given? How many? We have given the complete periodic table before you. What are
Yes, sir.
inner transition elements? What are inner transition elements, students? You will see that inner transition elements. What are inner transition? The lanthanides and actinides, in which the electrons are entering into F
F
subshell.
orbital.
F subshell. They are called inner transition elements. Inner transition elements are not, which ones, student? In which electrons are entering into, now which one? This will be n minus 2f. N minus 2f. Earlier I told you n minus 1d, n minus 1d and ns. What was the story? You had n minus 1d, ns. Now I'm saying n minus 2f. Therefore, 5d is there 4f. And the electrons start going into 4f. 4f means what? Which series the lanthanide started from? Which series the lanthanide started from? Lanthanide belongs to which period? Tell me.
Lanthanoid belongs to period 6.
Period 6. Okay, let us see. Sixth period you are saying. Then the last will be 6s2.
Yes,
6s2.
sir.
And the what will be that 5d? You have 5d. And before 5d, what you have? 4f. ठीक है? So this is
Yes,
n
sir.
minus 2f. Now, if this is ns, this is ns 1 to 2, then it could be nd 0 to 1. Let me tell you. And this will be n minus 2f 1 to 14.
14.
This is going to be the general electronic configuration of these elements. 4f and 5f. So
Yes, sir.
that is the reason that they actually are being, they are the inner elements of the transition elements. They are the inner elements of the transition elements involving n minus 2f subshells. Therefore, they have been named as inner transition elements. They both belong to which group? Which group they are belonging?
Group 3. Group 3.
Group 3. Okay, okay. Got it?
Sir, when we write this electronic configuration for lanthanoids and
I will
actinoids, the
explain. I
general
am, when
one.
I will come to that, I will explain more. Just Today the question was different. I am going to discuss lanthanide actinides as a separate in this. We will discuss everything.
Okay.
This is all about general things which small questions have been asked. I have taken for the D block elements. Here I am explaining what are D block element, what are transition element, and what type of questions have been asked. All have been taken by me. All these questions have been asked, which have been given. And students don't write the correct answers. They write something else. So what is the use? They lose marks without any purpose because they have crammed the things only. They don't understand. If you will cram, then again some problem is coming. My purpose is to explain everything. Now this whole thing is clear to us.
Yes, sir.
All the questions I took personally because they were asked and they have been answered here without any doubt. Okay?
Yes, sir.
Okay. Now what are the three series which we are mainly going to be talking about, student? Although our main purpose will be the first transition series, but you will see first transition series, which we call as the first transition series, students, which is
3D.
also called 3D series.
3D.
The electrons will be filled from 3D 1 to 3D. What you are having? 3D 1 2 3D 10. So we are putting it like this. You have student 4s 1 to 2 and 3D 4s 1 to 3D 1 to 10. ठीक है? Because
Yes, sir.
in one case you find half filled or completely filled, this s will never be zero, but it can be one or two. It can be one or two, and it is starting from scandium, atomic number 21 to what is the last which in the series? Actually, it ends with copper otherwise, because zinc is not a transition element, but
Transition
we
element.
find
Yes, sir.
we are having from scandium to zinc, we are saying the atomic number 30. This is a series, and this zinc. So if I say scandium to copper, but zinc is a D block element, it is not a transition element, but has properties similar. Therefore, kept in the transition metal series. Here we have first series, atomic number 21, 22, 23, 24, 25, 26, and the second one, students, starting from yttrium, this is
Okay.
21. See, atomic number 21, add 18, how much you will get? 39. ठीक है?
39.
Then
Yes, sir.
you are starting with the 4D series, which is called the second series. Second series, atomic number 39, yttrium, and you are going up to, student, the last one is cadmium. Cadmium is 48, and this, which group is this? Three group number
Group
three,
3.
4, 5, 6, 7, 8, 9, 10, 11, 12. Then cadmium is
Yes, sir.
in the 12th. What is the electronic configuration of cadmium? Which is that? What will be that? Here you, what was the electronic configuration? You are having 4s2 3d1, and here what you will have? 5s2
5s2 4d1.
4d10.
So,
So is it a
अच्छा
transition
हाँ
element?
cadmium is 10.
Is it a transition element?
No, sir.
Cadmium
No, sir.
is belonging to group 12. It is not a transition element because it is not going to form all partially filled D in ground or in a stable oxidation state. So coming to add now, further you add 18. What will you get? 9 add the
It will be
57.
57.
Okay. Now you added 57. This is coming lanthanum. But immediately you see
Okay.
there are elements which are missing. Which period is this?
This is period 6.
Fifth period, fourth period. ठीक है?
Yes, sir.
Sixth period. In sixth period, what has happened from lanthanum, students? Lanthanum. Here you can see that these elements are missing. So they are going to in the 4F series. 4F series, this starts in the sixth period. 4F series, which are the lanthanides. Lanthanides, students. So that is why now you have to add 18 plus 14 is how much? 32, because there will be
32.
14 electrons. So 40 plus 32,
Yes, sir.
72. Then 72 to you can see up to 80. So these are then your elements of the transition series, student, transition series. So 6D. Here you are, you have student cadmium, and here this is our sixth period. Sixth period. So sixth period will be in mercury. What will happen? What will be the electronic configuration of mercury? Hg. Mercury is 80. So what is the electronic configuration of mercury, student? In the last, what will happen? You will have 5d10.
It will be 6s2
5d10. So this is also
5d10.
not a transition
6s2
element.
5d10. Yes,
So
sir.
these group 12 elements are not transition elements as per the definition which we have defined. Group 12 element. This question has been asked, students. So we have seen how in these we are getting the inner, these are the lanthanides which we called as, because they are the inner elements of the transition elements. Inner elements of the transition elements, they will be called inner transition elements. Inner transition elements, students. And we have not talked about what is the general electronic configuration, students. Important question they have asked, what is the general electronic configuration? How we are writing? You have said n minus 1 d 1 to 10 n s 1 to 2. ठीक है? The general outer electronic configuration. Correct or any mistake? Have I written the right? Tell me. Is it correct? n minus 1 d 1 to 10 students. ठीक है?
Yes, sir.
We,
Yes,
this
sir.
is important. A question has been asked in the paper. Write the general
Okay.
electronic. And now the question is, when we write the electronic configuration,
Yes,
there
sir.
is no problem here. We have already told you 4s2 is there in this, and you started with 3d1, 3d2, 3d3, but here in this case, in this and this, you will have, what will you have? 4s1 3d5, and here in the case of this series,
3D5.
this and this. So there will be configurations which have been asked in the paper, students. What is the reason? You have already told the reason for this. What reason you have given? Half filled or completely filled orbitals are
More stable.
more stable. Why? There is exchange energy which is involved, because they can easily exchange.
Exchange
Electrons can
energy.
exchange. When they exchange, what will happen? Exchange energy stabilization. Exchange energy stabilization. So that half filled and completely filled orbitals, they have got extra energy due to exchange energy, more stabilization. More stabilization is there. These things are studied by spectra, actually. Spectra. Experimentally, these things are studied. Otherwise, I cannot write. In organic chemistry, I told you, we experimentally we study their spectra and everything, and then we give the, I mean, explanations. What we are trying is to explain them by the basic concepts which we are aware. Sometimes we may not be able to give a good explanation, student.
Yes, sir.
That could be possible. Experimentally, we see everything. How do I say that this is the electronic configuration? God bless you. How will I know? Okay, this is 3D, that here 4s1 3d5. Can I write it? Can I say anything? Only if I have atomic spectra, if I have studied their spectras or experimentally, then only I can say, okay, the result experimentally, it is proved that it is living like this. So now you explain why. So inorganic is all about explanations. If we can understand and explain them, that then we are getting full marks. If we can't, then what we are getting? Nothing. There are exceptions, as we will see in every case. So you have 3D series, 4D series, and 5D series. The first transition, second, third. 4 series is incomplete. Here you see elements you see which are not stable and radioactive.
Yes, sir.
Therefore, we don't have,
Radioactive.
and many of the elements are not existing. The numbers have been given, as you can see. So this is incomplete, students, uh, which is our fourth series. Therefore, students, our main purpose of this lecture has been, what are transition elements, what type of questions have been asked, electronic configurations, we are aware of them, and which series are there, what are inner transition elements, where are they located, and to be able to understand and write. So we must be able to, at least I am saying to the student, that this 3D series should be learned, and it should be on your tips, scandium to zinc and their atomic numbers. These are not going to be given in the
Okay, sir.
papers, so they expect students to know it. Other series, of course, I cannot remember the, even sometimes names and symbols are difficult. Atomic numbers will be provided, and if some important property is there, student, that will be discussed by us in the coming lectures.
Okay, sir.
So I will meet you in the next to discuss their properties, which is going to be a very important topic, very important topic. And plenty of questions will be there, which will be answered by us in our lectures. So we will meet you in our next class.
Okay, sir.
Okay, thank you.
Okay. Thank you, sir. Thank you,
Okay.
sir.